Hello, we're the Fundamentals, and here is our robot design. So the overall goal of our design was to launch for 5 points, retrieve buzz without alien interference for 45 points, and launch the rocket for anywhere between 5 to 15 points. The rocket launch has a variable range due to the potential for us to get second highest rocket in some of our rounds. Our rocket Our robot would undergo stage one calibration and approach, in which the back wheel will spin because of the motor, and the front wheels are mounted on the outside of the robot so as to not interfere with the aliens. Stage two, the buzz pusher will deploy by activating the solenoid. Stage three, in retrieval, the buzz pusher will come back and do one reverse, push the block over the track lip, and in stage four, our robot will be back in the starting zone and undergo a rocket launch for 24 inches to gain us 5 to 15 points.
All right, so now that you guys have a good idea of the basic functionality of our robot, I'm going to go into some of the failure modes, the most common failure modes we've experienced during the manufacturing and fabrication. So one of them was the fact that the dowel rods on the scissor lift experienced a lot of force while the scissor lift was extending upward, and it would actually cause the wooden dowel rods to break. So we replaced the wooden dowel rods with metal dowel rods to mitigate this issue. Another issue we found was the fact that the dowel rod would slide, or the motor would slide on the gear. So in order to fix that, we introduced a flange coupling connector with a screw that would fit into the hole, and it would tighten it so that it would not slide on the motor shaft. And this allowed the gear to spin despite the force it needed to generate on the lift and on the gear itself.
Yeah, I can talk about the fabrication approach and costs. Pretty much our fastening components were our main source of overall cost for our robot, as well as a third of our cost being towards the MDF, as Patrick touched upon. The 6 millimeter couplings and the stronger dowel rods were key components to adding to our robot.
Okay, and finally, in terms of ingenuity and implementation, essentially the pusher would flip the block multiple times. Then that would be to account for non-smooth arenas because there were different scenarios where the block could get stuck. And so we also hard-coded the values for set times. That way we could have consistent and achievable results. And finally, we also decided to implement the rocket lift with the scissor lift, and that just added the extra points to achieve the overall estimate that we were looking for.